There are two basic types of scientific numbers, those that are measured and those that are exact. And it's very important to distinguish between these two because calculations are handled differently depending on whether or not the numbers are measured or exact. Exact numbers are exactly known. There is no uncertainty associated with these numbers. We obtain these numbers either by counting or by definition. For example, we could say our cat had 6 kittens, or there are 38 students in the class. Both of these are examples of exact numbers obtained by counting. We know we don't have 6.5 kittens or 7.53 kittens. This number is an exact number. Another way to obtain an exact number is by definition. The other way exact numbers are obtained are by definition. For example, 1 week is defined as 7 days. A kilogram has exactly 1,000 grams. These numbers have no uncertainty associated with them. The other type of number are measured numbers. These are not known exactly because they're obtained through the process of measurement. In other words, they're estimates. To illustrate that, we can consider two people who both say that they are 34 years old. And when we look closer, we see they don't have exactly the same age, but they can both correctly say that they are 34 years old because 34 years is an estimate of their age. When we write measured numbers or represent measured numbers, it's understood that this value is uncertain. In general, we say it's plus or minus 1. Sometimes they consider plus or minus 2 and the last digit that's written. For example, if your odometer changes by a value of 12.3 miles, you have some confidence that it's accurate to within plus or minus 0.1 miles. In doing calculations with measured numbers, we need to recognize that the quality of the numbers, the uncertainty, relative uncertainty of these numbers going into the calculation are going to affect the quality of our result. In these calculations, we recognize that the result is only as good as the worst measurement. And in addition and subtraction, the worst measurement is determined by decimal places. Throughout the semester, we're going to follow the same protocol. You first write down the calculator answer, then go back and worry about the sig figs. So we look at this problem. So for this problem, we put these values into our calculator. We get a calculator answer of 9.701. Now we're going to consider the sig figs by determining which of these values is the worst measurement. So we look at our two numbers. 6.301 is estimated good to the thousandths place. 3.4 is estimated good only to the tenths place. In this example, the tenths place is our largest uncertainty. The least number of decimal places is our largest uncertainty. So when we write down our answer, we can only appropriately express it out to the tenths place. To remind myself of that, I'm going to draw a little line right here, right after the tenths place. That's a visual reminder to me that the reported answer needs to be rounded to the tenths place. Here are our rounding rules. If the first digit to be dropped is less than 5, we simply drop all the remaining digits. And that's the case that we have here. If the first digit to be dropped is 5 or larger, we're going to add 1 to the preceding decimal column. So again, we have the first number to be dropped is less than 5, so we're just going to drop all the numbers that are to the right of that column. So the correctly reported answer in this case is 9.7. So here's a quick protocol. So we add and subtract normally. We want to make sure we write down this calculator answer. So if we round wrong or if we get the wrong sig figs, we at least get 1 point. And then we note the last decimal column where all the numbers contain a sig fig. This is helping us identify the worst measurement. And then we recognize that our result cannot go beyond this decimal column. And then we report the answer after rounding. All right, so let's practice a couple of these. The first step is to write down our calculator answer. So here we have 459.121. And then we look at our decimal places. Okay, this again is the thousandths place. And the last decimal column here is the hundredths place. So our final answer can go no further than the hundredths place. We put our marker down there as a visual reminder of that. We look at the first number to be dropped. We see it's less than 5, so we just drop that and anything else that may follow it to the right. So our final answer is 459.12. The second problem, again, we write down our calculator answer first. Our calculator answer is 94.701. Looking at our decimal places, this is the thousandths place, and this is the tenths. So we can't go beyond the tenths place. We round down 94.7.